Exam 3, problem 2. We have a microwave, 2450 megahertz. We have a cup, 5 centimeters in radius. Place a 0.2 kilograms of water. You run the microwave for 2 minutes. Temperature of the water is increased by 75 degrees C. So the first question is, how much energy was added to the water? And we have the formula here, right? Q equals M, the specific heat of water, times delta T is the 0.2 kilograms times 4185 joules per kilogram degree C, right? And delta T is 75 degrees C. Okay. Let's pop over to Excel. Take a look at that. We've got 0.2, right? Equals 0.2 times 4184, 85. Was that a mistype earlier? 85, right? Times 75. So 62,775 joules. 62,775 joules. That's how much energy was added. That's A. What is the power being delivered by the microwave? Well, power is energy over time, right? So, and the time is 2 minutes or 120 seconds, right? Equals the total energy divided by 120 seconds is 523 watts. All right? Should I put that in there? 62775 joules divided by 120 seconds equals 523 watts. All right, assuming the power is only absorbed over the surface at the top of the water, what is intensity, right? So intensity see if I can get this right. Intensity is power per area. Not really sure why we're down on the next page there. Let's see if I can do something about that. Okay, I had to put up with problem 3 for a little bit. All right, intensity is power divided by area. Our area is pi r squared is pi times 0.05 meters squared. All right, pi times 0.05 squared, 0.007854 meters squared, right? So now we have the power, we have the area, so the intensity is the power divided by the area. Intensity is 66,606 watts per square meter. That's the intensity. So that gives us part B. Part C, assuming the power is only absorbed, oh no, that was part C, sorry. We've done part B, we've done part C. Part D, what is the peak electric field? Okay, so for part D, remember that the average intensity, which is what we've just gotten, is 1/2 C epsilon naught, right? E naught squared. All right, average intensity is 1/2 C epsilon naught E naught squared. From our formula sheet, epsilon naught, there it is right there. Boom, boom. 8.854 times 10 to the minus 12 coulomb squared per Newton meter squared. So epsilon naught 8.854 E minus 12. C is 3E8. All right, so we want half of C. Oh, need to solve this for, my bad. Need to solve this for the electric field. All right, so electric field squared is 2I over C epsilon naught. All right, and that means that U naught is the square root of all of that. 2I over C epsilon naught. Okay. 2I over C epsilon naught. We have the intensity right here. I. We have epsilon naught. And we have speed C. Okay, so we want the electric field, which is going to be equal to the square root of 2 times the intensity divided by speed of light divided by epsilon naught. 7,081.78 or 7,082. 7,082 volts per meter. Okay, that gives us peak electric field. Energy of photon is HF. H is Planck's constant. And F is the photon frequency. How many photons are absorbed in heating up your cup of water? So the energy of a photon equals HF equals 6.6626 times 10 to the minus 34. And Planck's constant, yep, joules seconds. Joules seconds times frequency 2450 megahertz. 2450 times 10 to the 6th hertz equals, so the energy in a single photon, let's put Planck's constants in. That is 6.626 E minus 34, 2450 E6. Okay, and so the energy in a single photon is the product of those. E are U photon, right? 1.62 times 10 to the minus 24. Joules. That's energy in a single photon. Now we have total energy is 62,775 joules. So the number of photons, right? Number of photons is Q divided by U photon. Right? Does that make sense? Number of photons is total energy divided by the energy per photon. All right. So number is going to be total energy, which this is Q up here. All right. So let's come down here. It equals the total energy divided by the energy per photon. So 3.87 times 10 to the 28th photons. It's a lot of photons. And there you go. That's the answer to problem 2.